Find the linearization of f of x equals negative 3 e to the x at x equals 0. So what does the linearization means? It means find the equation of the tangent line. That's the linearization. Just fancy talk for the equation of the tangent line, which we've done before, meaning the y equals mx plus b. We have to find the equation. Let me write that a little bit better. Equation of the tangent line. And the m, as you remember, is the slope, right? And the slope is the derivative. So we start with the function. F of x is minus 3 e to the x. And then we got to find the derivative. So f prime of x. Now, how do you do the derivative of e to the x? He's our favorite one. He doesn't do anything. He just sits right there like that, right? And what about the minus 3 in the front? Well, numbers in the front just sit there as well. So nothing happens. That's awesome. And we're supposed to do it at x equals 0. So what's f prime of 0? Minus 3 e to the 0. E to the 0 is 1. Anything to the 0 power is 1. So that's minus 3. And that's the slope because remember, derivative is slope. So that's our m value. So now we go, okay, so for the equation, we'll bring it over here now. We have the m value of negative 3. And now we just need to find the b. How do we find the b? Well, you got to plug in an x and a y. So to find b, plug in an xy point. What xy point? Well, again, they gave us x is 0. That's going to be 0. What's the y value that goes with it? Well, here's a picture of what we're doing. We're basically, so the red curve is the minus 3 e to the x. See that? And the blue straight line is the tangent line right here at x equals 0. It's where they intersect each other, right there. And see how they're really close to like right on top of each other, right around that vicinity? That's why the straight line is a good approximation to the curve. We call it the linearization around where they intersect. But like over here, the red and the blue are very different. And down here, the red and the blue are very different. But right around where they intersect, they're very, very close. It's a good approximation. So anyway, long story short, we got to find the x and the y value. So come on back here. We've got the x is 0. How do we find the y? Well, this is it right here. Remember, function values are y values. So we're going to say y equals, and then, right, we already know x is 0, e to the 0. So that's minus 3 times 1. That's minus 3. So y is minus 3. So that's the point over 0 down 3. And you can see, in fact, it is. Right here, that's down 3, isn't it? That's the point over 0 down 3. In fact, I'll just write it in normal colors. Over 0 down 3. That's where they intersect. And right around where that tangent line intersects, the blue and the red are really close to each other. Good approximation. Okay. So now we can finish by we can find the b. So now I'm going to plug in what? 0, negative 3. For the x, 0. For the y, negative 3. Because that's what I found from the original function. They're going to intersect at the same point. So this will become negative 3 equals minus 3 times 0 plus b, right? Just bringing these down. So minus 3 equals 0 plus b. So that's easy math. B is minus 3. So we have the equation of the tangent line. Now it's mx plus b. And now we know m, negative 3. Now we know b, also negative 3, coincidentally. So there is the equation of the tangent line. And that's the answer they got right there, minus 3x minus 3. That's what they call the linearization, or it's the equation of the tangent line. That's the equation of this blue line, minus 3x minus 3. So, and it intersects the red curve at the point over 0 down 3. And in that neighborhood, they're very, very close to each other. So we use in higher math and science. Curved functions are difficult to deal with. We like to, if they're really close to each other, the blue line, the red line are about the same. We'd rather work with that blue line equation. It's just easier. Anyway, so now let's use it. They say find f of 0.6, what it equals. See that shaky equal sign? That means approximately equal to. So you think, oh, you mean so you want to find f, oops, I thought I changed the color, but I did. F of 0.6, what it f of 0.6, well, the function, the original function, of course, is minus 3 e to the x. So f of x exactly equals minus 3 e to the x. So f of 0.6 is minus 3 e to the 0.6. That's what it exactly equals. We can get that on Desmos, minus 3 e to the 0.6. But that's not really what we want. Over here, we want to use the equation y equals minus 3x minus 3. Right. Why? Because this is the approximation. It's almost the same. I can't spell and talk. Let me try that again. Approximation. Because this this linear equation here, this equation is almost the same as this function, right? That's the whole point. That right around where they intersect, if you're close around there, the blue line, the red curve, they're almost the same thing. So it's almost the same thing. So I'm going to come back here and go, oh, okay, okay. So let's just plug the zero point 0.6 into that, and we'll get approximately the same thing. Let's go hit the buttons on Desmos. Minus 3 times zero point 0.6, minus 3. Here we go. Minus 3 times zero point 0.6, minus 3. What do I get? Minus 4.8. Minus 4.8. So it came out minus 4.8. Now, what's the actual value? If we really plugged into the actual, what's minus 3 e to the 0 0.6? Minus 3 e to the 0 0.6. Minus 3 e to the 0 0.6. Did I do that right? It's minus 5.466. Minus 5.466. Minus 5.466. Is that what it was? Yeah. So in other words, so there's our approximation, minus 4.8. There it is. And it says 7 decimal places, but the rest are just zeros. And then now, is this an overestimate or an underestimate? Is this approximation? Is this higher or lower than this one is the true value, right? Because this is plugging into the actual function. And over here, we just plugged into the linear blue line and got an approximation. This number is higher than that number. You think, right? Because they're both negative. Like if you're $4.80 in debt or you're $5.46, this is more negative. So this is higher. This is the higher number right there. So this is an overestimate. We went too high. Right? And so the answer is overestimate. See it on the graph? See how where are we at? We're at 0.6. So here's one, right? One, here's two, here's three, here's four. You can see. So 0.6 would be about just past this line, right? That's 0.6. So you go down to the curve, right there. See how the blue line is higher than the red line at over 0.6? So the blue, the estimate is higher. It's an overestimate compared to the red line. So, right, this is a higher number. This is minus 4.8. The other one's minus 5.466. And so there we go.